If we want to find a surface area, really all we're doing there is just finding the area of each of the faces of the thing we're looking at. So for our main families of things like here, if we want the surface area of a cube, then we have the area of any one face is just length times width, which is the same value. S is just s squared, and we have 6 sides on a cube. I'm thinking in terms of dice. So the surface area there would be 6s squared. Similarly, for a rectangular solid, a more general shape there, we have length, width, and height. So we have those pairs, 2 with the dimensions LW, 2 with the dimensions LH, and 2 with the dimensions WH for our 6 faces. That give us the surface area 2LW plus 2LH plus 2WH. And then for a cylinder, it's a little bit different. That in that case, we have 2 pi r squareds for the top and bottom, and then kind of cleverly, if we think about what would happen if we cut along one side and flattened it out, we actually have a rectangle there for the outside face that is defined with one height h, and then length given by the circumference of the circle on the top and bottom, which is given by the value 2 pi r. So these are our main basic pieces we have here for surface area. If you want to talk about things like the pyramids or the cones, you can make other similar constructions a bit carefully, but let's just get an example here to finish this stuff off, looking at some of our basic pieces. So for the given rectangular solid, we want to find its surface area. So there's nothing to it here. If we want our surface area for this, really all we have to do is just use the formula. That is, find the areas of our sides. So SA for surface area here will be 2 times the, I'll say that's width times height faces, 5 times 3, because we have 2 of those on the front and back, or left and right, depending on how you want to think about that. Then we have 2, call those length times width faces, the top and bottom, 5 and 8. That's a bad 5, jeez. And then finally, we have 2, let's call those, I don't know, width and height faces. I think I already said that, but the last pair is going to be in terms of the 8 and the 3, so that's going to be more like the front and back thinking in that way, but it's just a matter of arrangement and spinning. Point is, we'll have 2 8 times 3 types of faces. 5 times 3 is 15, times 2 is 30, 5 times 8 is 40, times 2 is 80, and 8 times 3 is 24, times 2 is 48. Add all of those up, and we'll get a total surface area here of 156 square yards in terms of our unit, in terms of our surface area. So one important thing to note there is that surface areas are talking about the areas cumulatively across all of the faces, so those are going to be in square units, whereas our volumes are cubic units. The surface area tells you about how big the outside is, and the volume tells you about how much space you have on the inside of it. And it's not the sort of thing we'll look at in this class, but you actually can get very weird with some of those things there. You can get shapes where you can have a finite volume, but an infinite surface area, which is a very calculus type of thing that we're not going to see too much in this class, but it's worth mentioning that geometry can get very, very strange once you start looking beyond 2 dimensions. Anyway, that's all we've got here for 10.5, so let's move on to our last section of the chapter, 10.6, to start talking about right triangles and trigonometry. See you in there.